Okay, welcome, wonderful people. What I want us to look at is specifically integration by substitution using indefinite integrals. So, I think we should start with this, the very number one, the very same one, this one. They say evaluate the indefinite integral in exercise 1 until 16 by using the given substitution to reduce the integrals to a standard form. So we have the integral of 2x plus 4. Let's do the very same problem, 5 dx. So they said the substitution should be 2x plus 4. So they say u equals 2x plus 4. So what we do in here, I can factor out this 2 and I can make a substitution of u to exponent of 5 dx. And I want you to be careful here. If this is your u, therefore your du will be 2 dx, because when you differentiate this you get that. So I'm here to the integral of u 5 times. Now where I see dx, I'll be writing du divided by 2, du divided by 2. And I think I've made a mistake by taking that 2 out. I shouldn't have done it in this way. So let me take it back the way it is, the integral of 2x plus 4 5 dx. Right, I have the integral of 2. Where I see this, I'm writing u. Where I see dx, if you make dx the subject of the formula, du divided by 2. And this goes once because it is a numerator and a denominator. You have u5 du. And what is u? The value of u is 2x plus 4. So now can you integrate this? Yes, I can integrate this. This would be u6 over 6 plus c. And I can put back the value of u as 2x plus 4 over 6 plus c. And this becomes your answer. Okay, let's go to the third one. The integral of 2x into x squared plus 5 minus 4 dx, and your u is x squared plus 5. So let's find du, 2x dx. That is fine. Let's go and substitute u minus 4. What is your dx? Du over 2x. Numerator denominator goes once. The integral of u minus 4 du. Can I integrate this? Yes. This will be minus 4 plus 1, which is minus 3. So u minus 3 all over minus 3 plus c. I can substitute back the value of u, x squared plus 5 minus 3 all over minus 3. So I can fix this. I can rewrite this as 1 over minus 3 x squared plus 5 to the exponent of 3 plus c. And that should be the answer for problem number 3. So you have minus 1/3 x squared plus 5 minus 3 plus 2. So this is what I have, because you can rewrite this as minus 1/3 x squared plus 5 minus 3 plus c. If you want this to be a numerator, if you want this to go on top, that has to be negative, and you have this. So whether you leave it like this or like that or like that, it doesn't really make any difference. That was number 3, very simple substitution. And then we go to number 5. Number 5 is the integral of 3x plus 2 3x squared plus 4x 4 dx, and your u is equals to 3x squared plus 4x. Of course it has to be your u, because when you differentiate this, you can be able to get rid of that. But let's see. The integral of 3x plus 2, where I see this, I'm writing u, but before I do that, let me differentiate this. Du equals 6x plus 4 dx. Do this so that you don't make any mistakes. So you have this as u to the exponent of 4. What is your dx? That is du divided by 6x plus 4. Okay, that is fine. You can take out a common factor in this one. I want you to be careful. 3x plus 2 u4 times du, there's a common factor of 2 here, so that you have 3x plus 2. Can you see that? Very important. This and this goes once, you will be left with 1/2. You can factor out that 1/2, the integral of u4 du, and this is 1/2. Can you integrate this? Yes, of course. This is u5 over 5, which can be rewritten as 1/2 into 1 over 5 u. It's 3x squared plus 4x to the exponent of 5, and this is the same as 1 over 10 3x squared plus 4x exponent 5 plus c as the solution to this problem. So number 5, we have 1 over 10 3x squared plus 4x exponent 5 plus c. So we are correct. We can go to number 7. On number 7, we have the integral of sine 3x dx. For somebody who has looked at my tutorials where I dealt with integration by parts of the basics, many of these problems were being solved, so you might want to go and look into that. So what is my u for this one? U is 3x. So I have let me see, sine 3x dx u is that. Okay, that's fine. So du will be 3 dx, the integral of sine u, and my dx is du over 3. Very good. This is the same as 1 over 3. Take it out. 1 over 3, the integral of sine u du, and this is 1/3. What is the integral of sine? Let me just bring in a paper very close. The integral of sine, it's negative cos, so this is negative cos u. Very important. So you'll have negative 1 over 3 cos 3x plus c as the solution for this problem. This was very, very basic. It's something that we have dealt with in integration by substitution. Negative 1 over 3 cos 3x plus c. Right, and then let's continue in this. And let us try now to look at number 9. And number 9 is the integral of sec 2t tan 2t dt, and your u is 2t, so meaning your du will be 2 dx. So what is happening here? What is happening here? Right, let us try to look into this very, very closely. We have sec t tan t dt. Right, du over dt. I'm sorry. not x, I'm sorry, this is du equals 2 dt, because I'm differentiating u with respect to t. I'm very sorry. So when we are here, what is it that we can do? What is it that we can do? Because this is an angle, this is an angle, and sec is 1 over cos, and the tan is sine over cos. So where do we go from here? Okay, this is the substitution. U is equals to 2t. Now we ask ourselves, what is the integral of sec 10? The integral of sec 10 is sec. Very important. The integral of sec 10 is sec. So in here, I'm going to say, okay, I know that, all right, I can say the integral of sec 2t tan 2t, and my dt is du over 2. Very good. So this is the same as 1/2. So I have 1/2 the integral of sec 2t tan 2t du. 1/2. What is the integral of sec 2t tan 2t? That must be sec 2t. This is sec 2t plus c. 1/2 sec 2t plus c. And we are just done. We are honestly done for problem number 9. 1/2 sec 2t plus c. And that is the solution. That was just the basic. Let's go to number 11, and we have the integral of 9r squared dr all over the square root of 1 minus r3. Okay, and our u is equals to 1 minus r3. This is the value of u. Okay, this is fine. I can find du, which is minus 3r squared dr. Okay, so I can rewrite this as the integral of 9r squared, the square root of 1 minus r3, and where I see dr, I'm writing du all over minus 3r squared. Very, very important that we see this. So r squared into r squared will go once, and 3 into this will go 3 times, so I have minus 3. Can you see that? So I can factor out minus 3, the integral of 1 over the square root of 1 minus r3 du. Okay, can I rewrite this? Yes, I can write this as 1 minus r3 to the exponent of minus 1/2 du, and I can integrate this minus 3. This is minus 1/2 plus 1, which is 1/2. So I have 1. In fact, I will have 1 minus r3 1/2 all over 1/2, and this can be rewritten as minus 3 2 into 1 minus r3 1/2 plus c, which is the same as minus 6 1 minus r3 1/2 plus c, or somebody might say 1 minus R3 plus C. Somebody might say that, but let's go and check. We are in number 11 and we have minus 6. The square root of 1 minus R3 plus C. Yes, we are very